The beginning of everything. The Big Bang. The idea that the universe was suddenly born and is not infinite. The Big Bang theory is the foremost explanation for the beginning of the universe. Simply put, it explains how the universe started and how over the next 13.8 billion years it expanded into the cosmos that we know today. All the information known about the theory doesn't come from looking back at how it began, but rather through mathematical theories and models. Up until the 20th century, most scientists saw the universe as infinite and ageless, until Einstein came up with his theory of relativity, which gave a better understanding of gravity, and Edward Hubble discovered that galaxies were moving away from one another. In 1964, cosmic microwave background radiation was discovered, a relic of early universe, and combined with other evidence, it supported the Big Bang theory. Improved technology helped us get a better picture of the Big Bang and the structure of the cosmos, and recent observations have given evidence that expansion is accelerating. But how can something come from nothing? First, the Big Bang wasn't an explosion. Rather, it was space expanding, going from smaller than a particle to the size of a football. Space expanded into itself. It can't expand into anything else because there are no borders. So by definition, there is no outside the universe. The quark era was hot and dense. Energy showed itself through particles that only existed for a small amount of time. It was basically a soup of free gluons. Gluons were turned into pairs of quarks that destroyed one another once they gave off more gluons. They interacted with other quarks, and more quark pairs and gluons were created. The heat made it so that matter and energy were basically the same. During this time, matter and antimatter were bumping into each other and destroying one another. Today, there is only matter and barely any antimatter, because for every 1 billion antimatter particles, there was 1 billion and 1 matter particles. At this time, there wasn't just one force, but several refined versions acting under different rules. At this moment, the temperature started to decrease, which was caused by the universe expanding to 1 billion kilometers in diameter. The cycle of quarks being born and converted back into energy stops, and at that moment, what was there was all that we had. During the hadron and lepton era, quarks began to form new particles called hadrons, which were protons and neutrons. Different combinations of quarks formed different sorts of hadrons, but little of which were stable. In the nucleosynthesis era, the universe had grown to 100 billion kilometers and had reached a temperature that let the neurons decay into protons, which formed the first atom, hydrogen. At this moment, the universe was filled with countless particles and energy. In the opaque era, things cooled and settled very quickly. Atoms were formed from hadrons and electrons, which made a stable electrically neutral environment. Many label this the Dark Age because there were no stars and the hydrogen gas didn't let visible light move around. When the hydrogen gas clung together after millions of years, gravity put it under great pressure, and this formed the stars and galaxies. The radiation emitted from them dissolved the stable hydrogen gas into plasma that still permeates the universe today and allows visible light to pass. And finally, there was light. But what about the beginning, before the Big Bang? We can't determine what happened for sure because the tools that we have break down, natural rules stop making sense, and time doesn't work properly. To understand what is happening, we need a theory that combines and unifies quantum mechanics and the theory of relativity, which is what scientists are working on now. But there are many questions left unanswered. Were there universes before our own? Is this the first and only universe? What started the Big Bang? Did it occur naturally from the laws that we don't understand yet? We don't know the answers and maybe we never will. There are 4 lines of evidence that we'll be talking about: the redshift of galaxies, Big Bang nucleosynthesis, cosmic background radiation, and the formation of galaxies. These are the 4 pillars of evidence that support the Big Bang theory. The redshift of galaxies is the discovery that the galaxies are moving away from us. In 1912, Vesto Slipher calculated the speed and direction of the spiral nebulae. He realized that these objects, which we know now to be galaxies, were moving away from one another. He theorized that they were part of the Milky Way. But in 1924, Edwin Hubble realized that the galaxies were not part of the Milky Way, but rather outside of it. He was able to determine that the galaxies are millions of light years apart, through discovering the relationship between the energy output of a star and the time it takes to pulse in brightness. This relationship helped him calculate how far away stars were in other galaxies. If the galaxies are far away and continuing to travel away from us, it supports a theory that billions of years before, the universe must have been located in a single point. Big Bang nucleosynthesis is the process believed to have taken place in the early moments of the universe, after the expansion. This was originally proposed in 1939 by George Gamow and Ralph Alpher. It explains the creation of light elements in the intense heat of the early moments following the Big Bang, through a process of nuclear fission. Heavier elements needed more heat and were created through a different form of nucleosynthesis. After the Big Bang, the density of the universe generated enough heat that it triggered a process of nuclear fission that combined the simplest form of hydrogen together to create lighter elements, such as helium and beryllium. Since the early universe was the same everywhere, this process occurred throughout the universe, which explains why, no matter where we look, there is roughly the same amount of the elements. Cosmic background radiation is the radiation left over from the formation of the universe and is detected in all directions of it. It dates back to the recombination era. It was first proposed by George Gamow and his team in 1948. In 1964, research teams attempted to detect the CMB, but it was accidentally discovered by Arno Penzias and Robert Wilson. Theories predicted that there was a massive release of radiation after the Big Bang, and that they are moving so fast that billions of years later, they shifted from visible light to microwave radiation. 400 million years after the Big Bang, the universe went through the age of reionization. During this time, groups of gas conglomerated into the first stars and galaxies. The ultraviolet light emitted from these stars and galaxies cleared and destroyed the neutral hydrogen gas. The process of reionization caused the universe to become transparent to ultraviolet light for the first time. The best theory that attempts to describe the universe before the Big Bang happened is the inflationary universe, which attempts to answer why there was a bang and what caused the expansion. The conventional Big Bang theory doesn't explain this. It only explains the aftermath of the bang. The inflation theory tries to explain how the universe expanded and how matter got into place. It is not a theory of the beginning, but a theory of how it evolved from the beginning. It tries to explain that what we see around us essentially started from nothing. 13.8 billion years ago, everything in the universe was converged into a single point. The Big Bang happened in darkness. Light didn't exist yet. In the early universe, time and space didn't apply. According to the inflation theory, the early universe expanded exponentially fast for a fraction of a second. The theory was introduced in 1981 by Alan Guth to solve several problems: the horizontal problem and the flatness problem. The horizontal problem is that no matter where you look in the universe, it is almost the same temperature. But this shouldn't happen, because if you look in one direction of space, you are essentially looking back in time. The light that hits a telescope travels at the speed of light, so it was emitted years before. This means that there is a boundary of about 14 billion light years in all directions. If you see the cosmic microwave background radiation, or the CMB, from 14 billion light years away, call this point A, then look 14 billion light years in the opposite direction, point B, you will see the same sort of CMB. But this shouldn't be possible because the 2 points are 28 billion light years away, and no signal moves faster than the speed of light. So how does this happen? Inflationary theory solves this because it explains that at the beginning of the Big Bang, the different regions were close enough to communicate. Then they expanded, to the point that they spread out and covered the visible universe. The flatness problem is about the geometry of the universe. Recent evidence shows that the universe appears to be flat. This is because the inflation flattened the universe. Similar to what happens to a balloon, the uninflated balloon has wrinkles, but as it expands, the surface smooths out. According to the inflation theory, this happens to the fabric of the universe as well. But just as it solves these two problems, there are various issues and limitations to the theory as well. The Earth is a little over 4.5 billion years old. The oldest material found is zircon crystals, which are roughly 4.3 billion years old. Life began on Earth roughly 3.8 billion years ago. It started with single-celled prokaryotic cells. A billion years later, these cells evolved into multicellular life. The life forms that we know now only began to evolve in the last 570 million years. It starts with the evolution of arthropods. Then came fish 530 million years ago. Then plants and forests evolved 475 million years ago. Mammals have only been around for roughly 200 million years, and Homo sapiens evolved around 200,000 years ago, which is only 0.004% of the Earth's history. Since the moment that life began, it has evolved and diversified. Life can be found everywhere on Earth. But how did life begin? Well, there are many theories that try to answer this, but we still don't have a definitive answer. Before we go into theories of how life began, there's a small clip showing the journey from the Big Bang to present times. Panspermia is the Greek word that translates into seeds everywhere. The hypothesis states that the seeds of life exist throughout the universe and can be spread from location to location. The processes of panspermia can include microorganisms traveling to locations on asteroids, meteorites, and comets. Three variations on the hypothesis are lithopanspermia, or interstellar panspermia, where rocks transport biological material from one solar system to another; ballistic panspermia, or interplanetary panspermia, where rocks transport biological material from one planet to another in the same solar system; and directed panspermia, which is when someone or something intentionally spreads life to other planets. This hypothesis doesn't attempt to explain where or when life began in the universe, just how it began on Earth. In 1984, a team of scientists in Antarctica found a meteorite that was blasted off of Mars 15 million years ago. In 1996, the meteorite was shown to have contained structures that could be remains of terrestrial nanobacteria. Several tests were done, looking for organic material. Amino acids and polycyclic aromatic hydrocarbons were found. Many scientists agree that it wasn't an indication of life, and others debated on whether or not it was contaminated by Antarctic ice. On May 11, 2001, geologist Bruno D'Argenio and molecular biologist Giuseppe Geraci announced that they found extraterrestrial bacteria on the inside of a meteorite, estimated to be 4.5 billion years old. They claimed that the bacteria had DNA not found on Earth. Sankar Chatterjee is a professor of geoscience and a curator of paleontology in Texas Tech University. He has put forward a new theory of how life began on Earth. He has said that life began in 4 steps of increasing complexity: cosmic, geological, chemical, and biological. He believes that he now knows how the first celled organisms formed after studying the 3 sites with the oldest fossils. In the cosmic stage, the Earth was struck daily from asteroids and icy comets. Chatterjee discovered a crater 25 miles wide off the coast of India. He said that the impact basins of 350 miles in diameter were the perfect crucibles. The meteorites that created these basins broke through the Earth's crust and brought the building blocks of life. These building blocks could be concentrated and polymerized in the basins. After studying the environment of the oldest fossil-containing rocks on Earth, Chatterjee said that these could be the perfect place where life could begin. The Earth's proximity to the Sun meant that the comets that crashed melted into water and other substances, which is the start of the geological stage. Geothermal venting heated the water and created convection, causing water to move constantly. The geological stage provides special dark, hot, and isolated environment that served as an incubator for life. Then began the chemical stage. The heat churning the water combined the chemicals and caused compounds to become larger and more complex. Eventually, the first life forms left the craters and went into newly formed oceans. Chatterjee believes that RNA and proteins emerged simultaneously. He goes on to say that if there was only RNA, it would dissolve very quickly without a catalyst such as protein. The proteins helped RNA replicate and metabolize. The RNA and protein used the membrane of fatty lipids brought by meteorites. Inside this membrane, the RNA and protein interacted, and eventually RNA gave way to DNA. And with the development of the genetic code, the first cells divided. The biological stage is the origin of replicating cells as they begin to process and transmit genetic information to their daughter cells. These cells were capable of Darwinian evolution. These first cells emerged based on a long history of chemical, geological, and cosmic processes. The origin of life is a question with many theories and creation stories trying to answer it. And we don't have a definitive one yet. And maybe we never will. But what we do have is a lot of people trying to get to the bottom of how life began on Earth.